we live or not? Let's check. And it looks like we are about to go live, hopefully. And yes, we are live. So what's up, guys? Mr. Analog here, and today I just felt like streaming because I'm pretty sick, as you can probably tell by my voice. And before I start studying for my school, I thought I might as well start streaming and, design some parts with you guys because you seem to like it the last time. So there doesn't seem to be anyone here right now, which is alright, because I just posted about this stream and I haven't posted the link to this actual stream yet. So, yo, OKL, how's it going? So we got some people here. That's good. And let me post the actual stream. Let me know how the sound is. I'm not really sure. Hopefully it's good. And yeah, join me as I stream and these parts live. Alright. 3 people watching. Yeah, pretty good, OKL. I mean, I have a lot of work for school and stuff like that, and a lot of stuff is going on with Analog, but pretty much good. Sounds good. Oh, okay, sweet. So, we have a few things that we need to work on today. First one, we need to design a wheel for bread. Second of all, we need to design the analog deck. So, if you could guys do me a favor and actually share this stream with your friends on Facebook and whatnot, that would be perfect. I'm gonna post the link to the Analog Facebook page as well. Yeah, there we go. Let's design some parts together. Like that. And that should be good to go. Alright, so I'm gonna start off with the wheels in a few moments and see if we can get some more people watching. And let's see who else we have here. And alright, seems like we're good to go. 2 people watching. Alright, let's wait for it a little bit. And let's see if we can post it anywhere else as well. Oh, right, we could. Share it here, probably. So, yeah, we're gonna see. Alright, publish this. And let's see, still 3 people watching. So I'm gonna get started with the wheels. So first off, when we're designing wheels, I'm using Autodesk Inventor Professional 2017. This process pretty much applies to all CAD softwares. Whichever one you're using, it's gonna work in a similar way. Now the buttons might be a little different, it might be called something else, but the concept is still the same. So first of all, what we need to do is we need to start a sketch on a plane. So we're going to click Start 2D Sketch. And right here are your two planes, your XZ and your YZ. So what we're going to do is we're going to actually draw it on the YZ plane because we want the wheel to be actually standing up. So let's click on YZ plane. And this right here is your center point. That's where X0, Y0, in this case Y0, Z0 is. So we're going to start drawing the wheel core. So first of all, we're going to be making 110 wheels, 110 millimeter that is. So what we need to do is, what I do usually is go 80 millimeter outside diameter, 25 millimeter outside diameter of the bearing slot, and then I do offset, and I do usually 5 millimeter wall, actually not 5, 3, sorry, 3 millimeter outside wall. You can leave this like it is because it's going to be actually solid. And we're going to extrude it, right? So we're going to click extrude, click on the parts that we want to extrude, and because this is a standard wheel, it's going to be 24 millimeters. Check the stream. Still 2 people watching, alright. So now that we have this, right, we have the bearing slot and the outside ring, we can start adding spokes. I know Brad likes wheels with a lot of spokes. That's what we talked about. So I'm going to go back on the YZ plane, click create a sketch, right? And what I usually do is I usually use slots just because it's easier. And I, click on the center point, click on the point on the inside line of the outer ring, and I do 3 millimeters. So you just put in 3 and enter. I go finish sketch, and we have a sketch of the actual spoke right now. So what I'm going to do now is click extrude again, click on the spoke drawing, and I'm going to go 10, right? 10 millimeters is a pretty safe boundary or pretty safe measurement here for a spoke. I'm going to click OK, and we have this, right? We have 1 spoke, but we can't have a wheel with 1 spoke. It's obvious. It would break. So what we're going to do next is click on extrusion, right? Right here you can see the history of the whole model. So if I close all this, you can see that we first extruded these 2 parts, right? And then we extruded the spoke. Now we want to take this action, which was extrusion of that spoke, and what we want to do is actually go and let me do it a different way. Because what we're going to do here is going to do again 24, so it's in one line, and then we're going to do the contour next, but that's alright, okay? For now we just have this, and we click circular, we click the actual point around which we want it to revolve, so we're going to click the inside ring, right, or the bearing slot, and here we can enter the number of spokes. So we can do 5 spokes, we can do 10 spokes, we can do 11 spokes, 15 spokes, right? So I'm just debating which one we should do. I think we're going to do 15 for now. And right now we have this crazy thing, right? Well, bear with me. What we're going to do next is we're going to create the contour of the wheel. So that means the roundness around here. So for this, we need to actually go and create a sketch on a different plane, on the XZ plane, because the contour is like that. So we're going to click create sketch, slice graphics, so we can see what we're doing. So this is the end of the bearing slot, this is the outside ring, and what we're going to do now is click arc, right? Let's see here, let's go like that, and like that, and we're going to create an arc, which is going to be 16 millimeters. And in order to actually do this, we need to close it off so we can revolve it later. And then we're going to create a line here, which is going to pretty much tell the computer what point or what line we should actually revolve the whole thing. So we're going to go for finish sketch, and we have this, right? Now what we're gonna do is click revolve, select the sketch that we did here, click axes, and click on the line that we did before. Click this button, which pretty much says extract the material as opposed to add the material, and we're gonna go OK. So now we have something like this, right? Not too bad. Next, what we want to do is actually get rid of all the sharp points of the design, because with aluminum, that's the worst thing you can have, because it's always where it starts cracking. Everything has to be rounded off. So I'm gonna click fillet 2mm, and we're gonna see if it works. Now there are different ways to do this as well, but this is how I do it, right? So we're gonna have to click on all of these. It's the most boring part of the whole thing, but there's no way for me right now to actually, do it different, because we're just starting off in the software. So like that. I'm just gonna go around, click on all these different edges, right? So that. And we're gonna keep clicking. One wrong click and it's messed up, so don't do the wrong click. And enter. So now it looks like this. And what we're gonna do is actually go 1.5. Wait for it to actually work. There we go. So now we have this, right? Pretty standard thing. Now we want the contour on the other side as well, because as you can see there's nothing. So what we're gonna do is actually click on revolution, mirror, click on the appropriate plane, which is this one, and click OK. Now we have it on the other side as well. So this is looking pretty good, but we're not done yet. So what up, Pinkster? So what we want to do next is actually get rid of this right here, the sharp lines. So we're gonna just again keep clicking like idiots till we have all the lines like that. Now in my designs, what I like to do is keep the radius is the same, or radii. I'm not sure what the plural of this word in English is. Ah, god damn it, and we fucked up. Right, this is not what you want to do. However, before we do any of this, I think I have an idea. Nope. What about this? Nope. Never mind, I don't. So again, we're gonna keep clicking. Click until we die. Catch me outside, how about that? So, and that one, that one. That one, that one, that one. That one, that one, that, that, that one as well, that one, that one, that one. We're getting close to the end, finally. That one, and that one. Let's check if we have everything, and we don't, so we need to click that one. Seems like that's all, folks, so click it and we have that, right? Oh, Pinkster, when can I probably expect to see these in the shop? Well, we're gonna see. I don't know. Depends if Brad is gonna like the design or not, but I think he's going to. So we have this right now, but that's not a finished wheel yet. We need to add the bearing slots. So I'm gonna click create a sketch. Go 22 millimeters because that's the diameter, the outside diameter of a regular bearing, and we go 7 because that's how thick it is. And we go mirror this on that plane. Okay, so we have it from both sides right now. Now the last thing we need to do is actually drill a hole in the middle for the bearing spacer. So we're gonna go 18. That's what I usually do. Extrude the shit out of it like that, and we have a relatively finished core. However, we're not done yet. What we're gonna do now, and somebody's texting me, but never mind that. What we're gonna do now is actually lighten up the wheel. So what we can do is actually get rid of parts of the material here. So we're gonna go like that, 4 millimeters. Extrude it like that, and then do the actual rotational repeating, and say 8. So now we got rid of all this material here. It's not much, but it's going to add up in the end. And another thing that we can do, probably, let's see if it's going to work, is actually chamfer the edges of the spokes by 1 millimeter. And yes, we can. What's up, Obama? This is going to make sure that the wheel looks lighter optically without actually sacrificing any strength. So let's do it all the way around and hope that my computer doesn't just freak out and crash. So let's wait for this. Hopefully it's not going to crash. Worst case scenario, we have it recorded, everything that we did. And if you're wondering why I'm vaping, it's because I'm actually trying to stop smoking again. So yeah, it's not because I want to be cool. Nothing cool about vaping, actually. So let's wait for this. And it seems like it's done. So let's do a few more. This is painfully slow, but there's nothing we can do about it. Another reason why I need Analog to start doing better, because I just spent all the money on my car and I need a new computer. Okay. So let's wait for this to load and do a few more. Let me get my lunch. My grandmother is a great cook. I wish you could taste it right now. So hopefully that's not going to fuck up. We have a last one to go. Hold your breath. Is it going to work? And still calculating. And enter. Let's wait. And there we go. Now on top of actually lighting up the part optically, it added this sort of thing here, which doesn't look that bad actually. So we have this so far. Vape Nation, what's up? So that's pretty much it. Now the next thing we need to do is actually make sure to mirror this. Alright, this can be patterned. Anyway, never mind. It's fine, I can do it later. Next thing we're gonna do is actually go and create a cam for it. So that's the program for the CNC. Now I'm a complete beginner in this, so bear with me. But we're gonna set it up. So we're gonna do milling, and the model is that, no fixture. The stock is as it is. Post processes we don't need. Alright, so we're gonna do a face first. So we're gonna create, actually click tool. Now I doubt I'll be able to do the whole thing, but I'm gonna show you the bare basics of how something like that is done. So we're gonna go back down here to tutorial, 50mm face mill, and as you can see it's on the wrong side, and that's because our coordinates are wrong. So we're gonna do select Z plane. Z is gonna be that. Click OK, and now hopefully when we go to face the stock, as you can see it's on the right side. So we're gonna click OK, and one thing that we actually didn't do is assign the material to it, but that's fine for now. Usually that's something very important. Now next thing we're gonna do is we're gonna do a 2D adaptive with a smaller drill. So we're gonna go 2mm ball maybe. Now we're gonna go 10mm flat, so we can get rid of most of the material here. Actually no, we couldn't, because we have all this here. And my software is fucking up again. There we go. So we're gonna go back to tutorial, and we're gonna go, yeah, let's do the 2mm ball. It's not very efficient, but it's gonna give us good precision for the radiuses that we have there. So we're gonna click OK. Ah, right, no pocket selected, duh. So we're gonna create, I have to select what it should actually machine. So let's try and click on this. Okay, and let's see what it actually did. So what we're gonna do now, we're gonna go simulate, click this so you can see the stock, and I need to do one more thing actually. It's 2D adaptive of this with a 10mm flat, and okay, there we go. And now we're gonna go ahead and simulate. So we have that, and we can pretty much start. So you can see that it goes around to create the roundness of the actual core. Let's just check if it does everything as we want it to. Yep, good. And now simulate the whole thing. So we're going to start off by facing, which we do to ensure that it's flat. Now we're going to start removing material. You can see that it's doing that right now. Speed it up a little bit. Right. Now it does this. So we have the bare round shape. And what you would need to do next is actually program all the pockets and the chamfers and all that, but I'm not going to get into it right now. So this has been pretty much it for the wheel, and this is where we're going to stop today. Thanks for watching. I'm actually filming a vlog today, so hopefully that should go up today or tonight. Until then, take it easy, and I'll see you guys in the next video.